All right, let's jump right in. Today, we're breaking down one of the most critical standards in fire protection engineering, NFPA 92, the standard for smoke control systems. Whether you're a design pro, an installer, or an AHJ, really getting a handle on this document is absolutely fundamental for life safety and, of course, for code compliance. So here's our roadmap. We'll start with the why, the whole reason the standard exists. Then we'll dive into the core design fundamentals, look at the actual systems and components, cover the all-important testing and maintenance, and finally, we'll clear up who's responsible for what. But before we get into the weeds of the standard, I want you to think about a really basic question. In a building fire, what do you think is the single biggest threat to human life? The answer really is the whole reason NFPA 92 was written in the first place. It's smoke, plain and simple. Statistically, it's not the flames that are the biggest killer in a fire. It's smoke inhalation and the disorientation it causes. Smoke can travel far, far away from the actual fire, making escape routes completely impassable. And that is the core problem NFPA 92 is designed to solve. So that brings us right to our first section, really understanding the purpose of NFPA 92 and what it's trying to accomplish. The standard's purpose is really multifaceted. First, it's about keeping smoke out of critical areas, like stairwells. Second, it's about maintaining a breathable environment so people can actually get out. It also aims to keep the smoke contained near the fire, and just as importantly, to create better conditions for firefighters to do their job. All of this, of course, ladders up to that primary goal, protecting lives and minimizing property damage. Okay, so now let's get into the design fundamentals. You see, effective smoke control isn't just about blowing air around. It's actually rooted in physics, understanding how smoke behaves, how it rises, and how things like building height and wind can affect it. And this image right here shows a key principle, smoke stratification. Because it's hot, smoke is buoyant. It rises and forms this thick layer up at the ceiling. So for a lot of these systems, the main goal is to manage the height of that smoke layer, to keep the space below it clear and breathable, giving people a safe path to evacuate. Now, NFPA 92 basically gives us two main playbooks. The first is smoke containment. Think of this as defense. You're using pressure differences to keep smoke from getting into places you want to protect, like a stairwell. The second is smoke management. This is more like offense. It's for big open spaces like atriums where you can't contain the smoke, so you have to actively manage it, usually by exhausting it out of the building. And here's what those two strategies look like. On the left, that's stairwell pressurization, a classic containment strategy. You're pumping air into the stairwell to create a higher pressure that acts like an invisible barrier, keeping smoke out. On the right, that's a big open atrium. You can't just pressurize the whole thing, so you have to manage that smoke plume, pulling it up and out of the building to keep the floors below clear. So, with those design principles in mind, let's look at the actual hardware. What are the tools we use to put these strategies into action? A smoke control system is really a team of components working together. You've got the muscle, the fans that move huge amounts of air. You've got the traffic cops, the dampers inside the ducts that open and close to direct that airflow. You've got the triggers, like smoke detectors. And then you have the brain, the control system that takes all the inputs and executes the plan, telling everything what to do and when. And this component right here, the Firefighter Smoke Control Station, or FSCS, is absolutely critical. This is the command center for the first responders. It gives them a clear, simple readout of what the system is doing, and, crucially, it lets them take manual control to adapt the system strategy based on what they're seeing on the ground. Okay, an amazing design on paper is great, but it's useless if it doesn't work when it counts. That brings us to testing and maintenance, the processes that prove the system actually works in the real world. The path to a compliant, working system is a very clear sequence. It all starts with detailed design documents. Then come preliminary checks of the components. But the big one, the main event, is acceptance testing. That's where the entire installed system is put through its paces to prove it can do what it was designed to do. And it's not a one-and-done deal. Ongoing, periodic testing is required to make sure it stays reliable for the life of the building. Now, as you can imagine, a system this complex requires a lot of coordination between different parties. So our last section is all about clarifying who does what. This table really lays it out. Think of it as a chain of responsibility. The designer creates the blueprint. The installer has to build it exactly to that blueprint. The authority having jurisdiction, or AHJ, acts as the reviewer and referee, approving the design and witnessing the final test. And once it's all done, the responsibility shifts to the building owner to make sure it's maintained and tested regularly. If any link in that chain breaks, the whole system could be compromised. And that brings us right back to where we started. This quote from the standard itself is the perfect reminder of the big picture. Every calculation, every piece of equipment, every single test is all done in service of one ultimate goal: the protection of life and the reduction of property loss. So, if you take one thing away from this, let it be this. A reliable smoke control system is an engineered balance. It's like a three-legged stool. You have design, installation, and verification. If any one of those legs is weak, the entire system is unreliable. And when we're talking about life safety, that balance is simply non-negotiable.